Welcome back to the Fujikura 100S Fusion Splicing Training Series. In this episode, we'll focus on prepping our equipment for splicing, the splice process, and some tips and features along the way. Splice quality starts before fibers ever enter the splice. The most common issues, high loss, inconsistent results, and rework, often trace back to inconsistent prep. Two quick safety reminders: always wear eye protection and always use a proper shards container for fiber shards. We'll use this SSCCL workflow: sleeve, strip, clean, cleave, and load to prepare our fibers for splicing. Following this order helps prevent missed sleeves and reduces contamination. Step 1, sleeve. Slide a clean protection sleeve onto the fiber before you expose the glass. This prevents the most frustrating mistakes in splicing, finishing a perfect splice and realizing the sleeve was never added. Step 2, strip. Remove the coating cleanly and consistently. A typical strip length is about 30 to 40 millimeters. The goal is to clean bare glass with no remaining coating or debris. Before you move on, take a quick look. You want a smooth, bare glass, no scoring marks, no coating residue, and no visible contamination. Step 3, clean. Use a fresh lint-free wipe moistened with approved fiber cleaning fluid or 99% or greater isopropyl alcohol. Wipe the bare glass thoroughly and remove residue and dust. This step matters. Clean glass supports cleaner cleave, and cleaner cleaves support better, more consistent splices. Step 4, cleave. The 100S kit uses the CT60 cleaver, designed for repeatability and efficiency. The CT60 supports one-handed operation, includes a 28 blade positions, and can manage through a smart link to help maintain consistent cleave quality. Load the clean fiber into the CT60 and make sure it is fully seated. One of the most important rules: never clean the fiber again after cleaving. It seems like it would help, but it can actually deposit contamination on a freshly cleaved end face. Step 5, load. Immediately after cleaving, load the fiber into the splicer without setting it down on any surface. Setting the fiber down increases the risk of dust or contamination on the end face. This is a simple habit that prevents a lot of trouble. Cleave, then load, no intermediate surfaces. When the CT60 is used with the 100S, the system can support active blade management, meaning the splicer monitors cleave quality and can direct blade rotation when needed. The benefit is consistent performance without tracking blade position. If you start seeing signs of poor cleave quality, the solution is often cleaver blade management and good maintenance, rather than trying to fix it after the cleave. Let's recap. Sleeve first, strip consistently, typically 30 to 40 millimeters, clean with approved fluid or 99% IPA, cleave carefully with the CT60, never clean after cleaving, and load the fiber immediately. Next, we'll focus on loading and ergonomics, how the 100S guide and loading features help you work faster and more comfortably, including fiber holder workflows and splice-on connector preparation. One key ergonomic feature of the 100S is the fiber placement guide. It helps you place fibers quickly and accurately without hovering over the machine, reducing strain and improving consistency. The 100S also supports expanded fiber setting range, which helps position fibers more confidently and reduces repetitive hand movements during setup. The platform supports dual fiber loading, allowing two prepared fibers to be placed into the machine efficiently, supporting faster workflows without sacrifice loading accuracy. Let's start with loading using sheath clamps. This is a common field workflow because it's fast and straightforward. Place the fibers into the placement guide area and set into position. Then close the sheath clamp to secure the fiber. As you load, pay attention to the clamp and retention features that help keep fibers controlled and protected during the handling. After loading, visually confirm fiber tip position. The goal is for both fiber ends to appear correctly centered and positioned at the recommended midpoints in the splice area before you proceed. If you're working with loose buffer fiber, the splicer includes a loose buffer feature that introduces protrusion to help stabilize the fiber. Only enable this feature for loose buffer fiber. Leave it all for standard coated fiber. Next is loading the fiber with fiber holders. This option can improve ease of handling by giving you a larger object to grip and helping maintain consistent positioning. The 100S kit includes fiber holder set plates. These support a fiber holder workflow that can reduce handling errors and improve repeatability. With fiber holders, the focus is on consistent placement and controlled handling, so the fiber end lands in a repeatable location each time. From an ergonomic standpoint, the goal is repeatable loading without excessive bending, hovering, and repeated micro adjustments. The placement guide and expanded setting range are designed to support that. The 100S also used for field termination workflows, including splice-on connector applications. In these cases, use the correct holder and setup hardware for your connector process, and follow the connector's official instructions on job specifications. Arc calibration is one of the most important setup steps you can perform. It directly affects splice quality, loss performance, and consistency in the field. Arc calibration allows the splicer to adjust fusion power so fiber melts correctly under environmental conditions. Temperature, humidity, air pressure, and altitude all affect how arc power is needed. Arc calibration compensates for these variables. Without proper arc calibration, you may see high splice loss, inconsistent results, or unnecessary rework, even if the fiber prep is perfect. A good rule of thumb is to run an arc calibration at the start of each workday. Anytime environmental conditions change significantly, after transporting the splicer, or the splicer results begin to degrade. Before starting arc calibration, prepare 2 standard fibers just as you are going to perform a splice. Load both prepared fibers into the splicer, ensuring they are positioned correctly before continuing. From the Ready screen, select the arc calibration function using the on-screen shortcut and menu option. Once the fibers are loaded, start the arc calibration process. The splicer will automatically ignite the arc and measure the fusion behavior. This process only takes a few seconds. During the calibration, the splicer evaluates arc behavior and adjusts fusion power accordingly. When calibration is complete, the splicer stores updated arc parameters and returns to the Ready screen. It's important to understand that automatic splice modes are not a substitute for arc calibration. Auto modes make small adjustments between splices, but they rely on properly calibrated starting point. The best practice is simple: calibrate first, then splice. This sets the foundation for consistent results throughout the day. Once arc calibration is complete, the splicer Ready screen is displayed. The splicer is properly prepared for the next step in the workflow. Now that we've completed all necessary prep steps, we can start splicing. Before you start, confirm you're at the Ready screen, your work surface is clean, and your prep tools are staged. In auto mode, the splicer monitors arc power with each splice and makes minor adjustments as conditions change. Auto mode also identifies fiber type and selects parameters based on detected fibers. Make it a strong default choice when fiber types vary or you want maximum automation. Now we run the full workflow using SSCCL. Sleeve, strip, clean, cleave, and load. Before starting the splice, visually confirm fiber tip position. The tip should appear correctly centered and positioned at the recommended midpoint in the splice area. Close the wind protector to begin the automated sequence. Depending on your selected automation level, the splice may start automatically once both fibers are loaded. During the splice, the 100S performs fiber inspection, core alignment, gap setting, arc discharge, and tensile testing. Splice time varies by mode. In auto workflows, a typical splice completion falls in a single-digit or mid-teens second range, depending on the selected mode. After the splice completes, the splicer opens the wind protector automatically so you can safely remove the splice fibers. A splice isn't complete until it's properly protected. Poor sleeve placement or rushed heater handling can undo otherwise perfect splicing. Start by sliding the protection sleeve toward the splice area. At this point, don't drop it into the heater yet. Positioning comes first. One of the most reliable ways to center the sleeve is the pinch and tilt method. Pinch the fiber opposite the sleeve with one hand. With your other hand, hold the sleeve side of the fiber. Gently tilt the fiber. Gravity and the sleeve's movement help in natural center over the splice point. The goal is even coverage on both sides of the splice. Take a second to confirm the sleeve is centered before moving to the heater. Improper alignment can lead to uneven shrink or exposed splice areas. Hold the fiber steady until the heater captures the sleeve. Releasing too early can allow the sleeve to drop below the heat element, causing incomplete shrink. The heating cycle typically completes in 8 to 15 seconds, depending on the selected heater mode. Because splicing and heating operate independently, you can begin staging the next splice while the heater completes its cycle. After heating, remove the protected splice and place it in a safe area to cool. The sleeve will be hot. Avoid handling it until it cools completely. A properly heated sleeve should be evenly shrunk, straight, and firmly bonded around the splice.